All right, this is one of the last things that we're going to go over before we do the EOC, this one and orthogonal drawings. This is something I found off the internet. It's just kind of like a supplement to help get us through here. Networks are made up of nodes. Okay, so all of these endpoints are nodes. Okay, all of the lines connected together, like this entire thing, that is the network. Okay, there's some different things that we're going to talk about in regards to these networks. Okay, so one of the main things that we're going to want to know about these is if they're traversable. Okay, and basically what that means is, are they traceable? Okay, when I mean traceable, I can go through a point, but I can never repeat a line more than once. Okay, so like for instance, if I go from here to here, I can go through the diagonal and then back this way and here. I never went over any line twice. I did go through the same point, but I never repeated a line. This is traversable. Okay, in other words, it's traceable. I never had to lift my pencil. Now, the more complicated these things get, there's going to be some rules that we're going to use. Okay, first of all, it must be fully connected. I can't have anything just hanging out there. And the reason we're going to go by these rules is because sometimes it's going to become more difficult to manually trace them than it is to start using some of these rules. So rule number one is it must be fully connected. Okay, if you go over here to the left, to the right, another one is that all vertices are even degrees. We're going to talk about what that means. So if I look up here at the vertices, or another word, a node, this one here has how many lines coming into it? 1, 2. So this one would be a degree of 2, which is an even number. Okay? So this one is an even, this is a 2, this is a 2, and this one is a 2. These have 1, 2, 3 lines. 1, 2, 3. This would be a 3, degree of 3. So it would be an odd node. This one here would be 3, which would be an odd node. Okay, that's going to make some more sense when we go a little bit further here. Okay, so if I have a picture where every single one of those nodes are even, then I can automatically say it's traversable. Okay, now the next case would be is if I have exactly 2 vertices that are odd and the rest are even. Okay, so let's look at this one that I just labeled. I have exactly 2 odds and the rest are even. I can say that this is traversable. Okay, in other words, there's some way for me to trace this without picking up my pencil. Okay, so here would be the way that I could trace this. I could start here, down, over, up, this way. Okay, I never went over one twice. Okay, these are going to get a little bit more complicated, so we're going to keep following these rules. Another rule would be if more than 2 vertices have odd degrees, then it is not traversable. Okay, so if at any point in time I have more than 2 odds, it is not traversable. Okay, we talked about what the degree is. That's how many edges go into each of these. So let's kind of look at these. This one would be a 2, 2, 2, 1, 2, 3, 4, 5. So that one would be an odd node. This is a 2, a 2. There's 3 in that one. 1, 2, 3. This is a 2 and a 2. Okay? This has exactly 2 odd and the rest are even. This one would be traversable. Okay? All right, let's look at this one. This one is an even. 1, 2, 3. This is an odd. Even. 1, 2, 3. This is an odd. I have exactly 2 odds and the rest are even. This one would be traversable. Okay. Let's look at another one. This one has 2. That makes it even. 1, 2, 3. This one would be odd. Even. 1, 2, 3, 4, even. 1, 2, 3, this one's odd. Okay, it has exactly 2 odds, the rest are even, so this one would be transversable. Okay, we're going to skip this one. It's a little bit jumbled. I feel like we're losing room here on this camera space. Okay, so this is the notes for page 1.